So in this video, we're going to be going over lenses. So if you would like, please pause and read the question. So the first thing we're going to find is the location of the final image as well as the height of the final image. So one equation we're going to need is one of the lens equations. 1 over s plus 1 over s prime equals 1 over f. So s is the location or the distance, horizontal distance of the object after it has passed through our lens. So what we're going to do is we're going to draw the direction that the light is going to and how it refracts when going through the lens. So right here is our object. So we are first going to draw a line that goes straight. And then once it gets to the lens, it is going to go down and through the focal point. And now we will draw another line going from the object through the focal point on the left side and straight through the lens. And then when a light ray goes through a focal point and hits the lens, it'll go horizontally. I'm going to drag these to make these bigger. So once it has done that, okay, and then this is where the image will be after it has passed through our lens. And now we will draw light rays from that point. And I'm just going to move some of this stuff over. So now we will draw a line going from our image and have it go through the focal point. Or not the focal point, but have it go straight through the center of the lens. Because when a light ray goes through the center of the lens, it will not bend. And now we will make an object, or not an object, make the lens go straight, horizontal, and then have it bend to the focal point. Now it may not look like it, but these rays are actually diverging, so they should never meet. So we will have to draw we'll have to draw virtual lines to create a virtual image. And these lines will look something like this. They will end up going all the way down here where they eventually meet. Now, this may definitely not look perfect, but this is just a rough example because these are definitely not straight. But they will meet at some point, somewhere all the way down here. So this is a visual of how our light ray should work and where our objects should end up. So we will do the math for lens 1 first. So here we see that this S right here is going to be the initial object, or the initial horizontal distance away from our lens of the object. So, as stated in the question, we see that our object is 6 centimeters in front of the objective lens. So we will start with 1 over 6 plus, and then this is the S prime acts as the final distance after it has passed through the lens, which is what we're trying to find. So 1 over S prime. And then we need the distance of the focal length of the lens we've passed through, which, if we go up to our question, is 4 centimeters. So we will have 1 over 4. And now we just solve. So we will move our 1 over 6 over to the other side. So we'll end up with 1 over s prime equals 1 over 4 minus 1 over 6. And now we just plug that into our calculator. And when we plug all that into our calculator, we will get some decimal. And then, since we have a 1 over s prime here, we need to do the inverse, and then we'll end up with 12 centimeters. So if we look at our image, or our my terrible drawing here, we have that this distance right here should be 12 centimeters. Now let's find the height of our image. But before we find the height, we have to get our magnification value. So we'll first lay out what we know. We know our s, which is equal to 6, our s prime, which is what we just found, which is equal to 12, and another equation that we need to memorize is our magnification, which is m equals s prime over s. So we do that, we get a magnification of 2. So now we can find the height. And the equation for our height is going to be m is equal to y prime over y. And y prime is what we're trying to find. So we can rearrange this equation so that it's m y equal to y prime. So let's go back to our question, and we see that our height is 1 centimeter tall. So what we can do is we'll have m 2, then our y 1. So our ending height will be 2. But we have to remember our image ends up below the x-axis. So we need to make sure it is negative 2 centimeters. Okay, so now we can do the second lens. And to get the location of our object, our new object, remember our new object is right here, we have to find the distance between the lenses, or what the distance that separates the lens, which we found is 16. So what we'll do is 16 minus 12, which is equal to 4 centimeters. And that is this distance right here, and that's what we need. That's going to be our s value. So again, we'll use the same equation, 1 over s. You already know it, it's right here. So I'm just going to plug in our variables. 1 over 4 plus 1 over s prime is equal to 1 over our distance of our focal point, which is 5 centimeters. So we'll put 5 right here. 5. And now we'll solve. 1 over s prime equals 1 over 5 minus 1 over 4. And when we plug that into our calculators, we get negative 20 equals negative 20 centimeters. Now that actually makes perfect sense, because remember, our rays on the right side of this, our eyepiece right here, are diverging, so they are never going to intersect, but they do intersect all the way back here. So our image is going to be, or our new S value is going to be this location, this distance right here in centimeters. So it'll be negative 20 centimeters, which will be all the way back here. Now let's find the new height. Or first we'll find the magnification. So we'll do negative 20 over 4, and this will give us a magnification of 5, or negative 5. So we can then take this negative 5 and plug it into our formula to find the height, which is, remember, my equals y prime. So we have negative 5, and then our initial height was the height that we found from lens 1. Where was that? Which was negative 2 centimeters. So we have negative 5 times negative 2, and that's going to be equal to 10 centimeters. So this distance right here is going to be 10 centimeters. And that is our final answer. But remember, oops, made a mistake, it's going to be negative 10. Because remember, it's going to be below the x-axis. Actually, this is going to be way down here because my image is terrible. So to summarize, our final answer is going to be our y is going to be at negative 10, and our s prime is going to be at negative 20. And those are the coordinates to our final image, which is going to be somewhere all the way down here.